All right, I got 11 on my watch, so go ahead and get started. Welcome, my name is Matthew. I'm not Seth. I'm filling in for today, though. Did you tell you what we'd be talking about today? Okay, this is a talk I'm excited about. Today we're going to talk about gambling and math that goes into gambling. And I'm not going to tell you how to beat the casino. That's not the goal of today. The goal of today is to educate you on the kind of math that goes into these games, and because there's no place on this planet where more mathematical atrocities are committed than in a casino. So you guys look too young to go to a casino, but if you do one day, you're going to find that fact out. So we're going to start with a very simple game, that being the game of roulette. And we're going to talk about the math that goes into this game in a moment, but first I want to start by introducing the game and how it works. So it's a very simple game. It's a game where there's a metal ball that rolls around, and it falls into one of these 38 numbers. There's the numbers 1 to 36, and also 0 and double 0. So a total of 38 possibilities. With numbers 1 to 36, 0, and double 0. And every number also gets a color. There's either red or black, and 2 of them are green. So there's 18 red, there's 18 black, and there's 2 that are green. And there are many bets that can be made on the roulette table. So you can bet on any one of the numbers, and there's other bets as well, but one of the most popular bets is either red or black. Now, if you bet on red, and a red number comes up, you win. It's pretty simple. If you bet on black, and a black number comes up, you win, and otherwise you lose. If you win red-black bet, you win whatever you bet. So, this is a math class, and I have a question for you guys. I don't want you to yell out. I want you to keep it in your head for a moment. Is this fair? Is this bet fair? If you bet on red and you win your money. And I want you to tell your neighbors, what do you think? Is this going to be a fair bet or not a fair bet? And it might not be an easy question, just throw some ideas out there. But I've been told that you've talked to each other before, and so I'm going to ask you to talk to each other again. And see if you come with an idea. Okay, what do we think? Thumbs up, you think it's fair. Thumbs down, you don't think it's fair. We have a mix of the two. Would anybody like to defend their opinion? Yeah, go for it.
It's not perfectly fair because there's an 18 in 38 chance you win, which is not 50.
Yeah, what are the odds? If you bet on red, what are the odds that you win? Right? So there's 38 possibilities. 18 of them are red. So winning on red has an 18 out of 38. Now where's, I heard a lot of 50-50. Why would you, it's a good idea to think 50-50. Intuitively, it feels 50-50 because there's 18 red and 18 black, but it's these 2 green that mess your whole day up, right? And that makes it, instead of 18 out of 36, which would be 50-50, it's 18 out of 38, which is a little bit less. I think it's something like 47% and some change. And so they're paying you like the 50-50 bet, but it's not 50-50. And every single game in the casino is designed this way, where they figure out what are the odds of winning. Okay, what would they have to pay you for it to be fair? And they pay you a little bit less than that, because you can't win. Otherwise, they wouldn't be in business. But, oh, by the way, if you have any questions at any point in time, raise your hand and ask me. But I want to dive into a little bit of the more specific math on how we can compute something called the house edge here. So, our chance of winning, we said, was 18 out of 38. What would be the chance of losing? Somebody yell it out.
20 out of 38.
Thank you. Love the enthusiasm. 20 out of 38. So the way we can calculate how much we win or lose on average, and let's write out that question. how much won or lost on average? Question mark. Should look like an 8, not a 6. So the 18 out of 38 times that we win $1. So I'm going to multiply those two together. And the 20 out of 38 times that we lose $1. And if I subtract those two, I get 18 out of 38 minus 20 out of 38, which is 2 out of 38. And that's a number that's about, oh, very important, I left out the negative sign. If it was positive, we'd be making money, but if it's negative, we're losing money. And that's about negative 0.0526. And you don't have to do this in your head, you get a calculator to do this. And the way to interpret this number is this is the edge that the house, the casino, has over the player. And this is called the house edge. And the house edge in this game is about 5.26%. And so when people call this game a 50-50 game, you're actually losing 5% for every dollar you bet. It's actually kind of far away from 50-50. It's how casinos can mess with your intuition. It's a game that feels 50-50, but it's very far from it. And the way to interpret this, in other ways, for every $100 you bet, you lose about 5.26. And every single casino, again, is designed this way. And I want to try one other type of bet. So I showed you the red-black bet. But you can also bet, yes, go ahead.
Well, I came in a little late, so what do you need to do to win? Do you
Oh,
land on one red?
If you
and
bet
one black?
on red and red comes up, then you win. Yep. You bet on black and black comes up, you win. Well, the other thing's a green bet, so. Yeah. Good question. Stop me if you have any other questions as well. So that's the house edge for the red-black bet. But what if you bet on an individual number? So let's try. Individual numbers. So there are 38 possibilities. So if you bet on one number, the odds of winning is 1 out of 38. 38. And I think it's clear enough that the chance of losing is 37 out of 38. So out of the gates, this feels like a much different bet than red-black, right? You have a much less probability of winning. And I think it's clear that if they just gave you your money back, it would probably be a bad bet. You'd be losing so often that you would never make up for it. But they don't pay you just your money back. So when you win, you make $35. And when you lose your $1 bet. And hopefully your intuition, after what I've said so far, should tell you this is probably not a good bet, otherwise it wouldn't be there. My question that I have for you is, which of these two bets do you think is better? If you had to bet, if you had to be a gambler for one day and you had to bet on one of these two bets, would you rather bet on the red-black bet, where you win more often, but you win less, you win $1 at a time, or would you bet on one individual number, but win more every time? And I want to give you the chance to tell your neighbor what you would do if you were in this situation.
Yeah.
All right, so I want to get your opinions, but I just want to clarify first, and a really good question. So is it $35 no matter what you bet? No, that's for every $1 you bet, you make $35. If you bet $10, you win $350. So what do we think? Would you rather do this bet, the red-black one, or the single number bet? Red-black, raise your hand. And what about single number? Raise your hand. That's about 50-50. Would anyone want to give a reason for why they picked one or the other? Yeah, go ahead.
The math you're explaining with the $350 assumes that you would at some point win, which the chances are
So
just
low, right?
so low, versus on the right, not great either, but a lot higher.
Yeah, what do you think?
I'm going to disagree with that by saying when something's like close to 50-50, like if you flip a coin, you know that if you do it over and over and over again, like if you're at the casino for a whole day, it's gonna come out to about half of each, and then you're gonna lose money. At least with the other one, there's like a slight chance you could make money, even though it looks like the chance is slighter.
These are both really good points. I love what you said about how if you do this again over the course of a day, because you can walk into a casino, play for 5 minutes and win, but eventually, like you keep in the red-black bet, this is going to come to get you. So let's try to be more precise here. Let's actually compute the house edge for this one as well, in the same exact way. Let's take the chance of winning. So how much, that's not how much won lost on average. So the 1 in the 38 times that we win $35. And the 37 out of 38 times that we win, we lose $1. Did this right? Good, I did. Okay. If I subtract these two, I have 35 over 38 minus 37 over 38, which is -2 over 38, which is approximately -0.0526. Does the number look familiar? It does. It's the same number as over there. And so the real answer to which one of these bets is better, they're the same thing. I mean, if you sit there all day and you only play red-black, or if you sit there all day and only play this one, on average, you're going to leave with the same amount of money lost, which is that same 5.26%. Now, the difference in playing is this is going to have a lot more variance, which just means you have much wider swings. But eventually, they're both going to come for the same number. That 5.26% is going to come for you, and eventually you're going to lose all your money. Any questions about this idea? Okay, so I want to do something that I think will be fun. I want to actually play. I want to give you the chance to make for fake money. I'm going to give everybody $10 of Monopoly money. Write it down. And we're going to play 5 times. This is not just going to be for the sake of being degenerates. We're actually going to, there's going to come back to some math and some interesting ideas. But I think it'll be better if we play for a moment first. So write down in your paper $10. And for every time you play, you can bet on whatever you want. Either bet on one individual number or bet on red-black. Let's see if this works. Here's our little roulette table. All right. Everybody written it down? Okay, I'm going to spin it, or at least keep it in your head. And bet one more time, and we'll end there. Okay, tally up your numbers. Who ended up, yeah, what's your question?
Oh, I was wondering.
Oh, you look like you had a question. Who ended up winning money? Who ended up losing money? A few more losers than winners, but we did have some winners, right? Raise your hand again if you won some money. So the reason I'm doing this is because I keep harping on this number of 5.26%, but it is possible to go in on any given day and win. So what's going on there? Well, the idea here is we're getting to the idea of variance. And just because you win over a short period of time that is such a small sample size, you can't begin to see what's happening here. Another point I wanted to bring up is that we got red 3 times in a row, and then 1 black, and then 1 red. My question for you, another question I want you to discuss, which color do you think is more likely to show up next? It's a silly question, it might feel like that, but tell your neighbors, which color do you think will show up more likely next? We had 3 red, and then 1 black, and then 1 red. All right, what's the answer? Which one's more likely to show up next? It's the same, right? So, if you get red 3 times in a row, and then black once, and then 1 red, what does that have anything to do with the next roll? Nothing, right? And the mathematical word for this, because it's supposed to be a math talk, is these events are independent. Each roll is independent. And what that word means is that the previous roll has no effect on the next one, or no impact. Impact. And I hope that feels like an obvious concept, especially sitting here in a math class. But if you go to any casino, you're going to find people reading into these patterns like it's astrology. You know, and it seems silly, but sometimes I question, how could you possibly think that the next one is going to be one color or another, just because of what the previous one was? And there's a very big concept in that shows up in gambling or in psychology in general, which is confirmation bias. And this is getting away from math and into psychology, but it's an important part of the story. Anybody heard of confirmation bias before? Yeah, it's a fairly common idea. And the idea, confirmation bias, is the tendency to interpret new evidence as confirmation of one's beliefs or theories. And so, if you look at this and see 3 red, 1 black, and 1 red, and maybe black comes up next, and you're like, oh, I predicted it was going to be black, and therefore it came up. Clearly I'm right. And if it doesn't come up, you'll find a way to dismiss it because it doesn't confirm your biases. This is a very dangerous thing. And this is the reason why casinos are so profitable and so dangerous. It's because of one, this variance where sometimes you can win, and two, it's very easy to find patterns where there aren't any. Are there any questions on these concepts? Oh, we got a question. Okay, so I want to go into one other topic in this same idea. Hopefully this is enough to convince you that on any given roll, you can't possibly win. Well, you can't possibly have an advantage. You can win in the short term, but eventually that'll come for you. But some people will say, I have this fantastic betting scheme. This betting scheme that can beat the house edge, and I promise it works. So we're going to look into it and dissect why it may or may not be correct. So this person's betting scheme, we're going to start by betting $5 on red. And if I lose, double it and go again. And repeat until win, and reset at $5. So I have a quick example. So you start at $5. If you lose, then you'd bet $10. If you lose again, then you'd bet 20. If you lose again, then you would bet 40. And so on until you win. And you reset back at $5. And the idea of this is that if you lose and you double it, and you win this bet, then you make back all the money you lost plus some. So before we get into actually the specific mathematics of why this doesn't work, conceptually, I want you to discuss with your partners what are the possible pitfalls of this strategy. Okay, I heard some good ideas. What's one of them you'd be willing to share with the class? What's the possible pitfall? Yeah.
This operates under the assumption that at some point you will win.
Yeah, you gotta win eventually, because if you keep doubling, and you keep doubling, and keep doubling, eventually you're at 80, 160, 320, 640, then you're sweating really bad, and you better win then, and if you don't, then you lose everything. Another way to look at this conceptually is a moment ago I had on the board that each roll is independent. And if we just look at that roll right there, we know the house edge on that roll is 5.26%. What about that roll? 5.26%, or that one, or that one. Whatever you do in the next roll, the previous one, does not change the fact that in each individual roll, you have there's a 5.26% house edge. And eventually that big loss streak is going to happen, you'll lose everything. But I think it would be interesting to look into what's the probability of losing like 7 times in a row. You know, because in your head you think it would be rare, and it is, but it will happen eventually. And just how often will it happen? I want to write what are the odds of losing 7 times in a row. And if you have a question like this and you don't know how to attack 7 times in a row, what I would start with, okay, what are the odds of losing 1 time, then 2 times in a row, 3 times in a row, and see if you can extrapolate that to 7 times in a row. And we know the odds of losing once is 20 out of 38, and that's about 0.526, 52%. Now, a harder question might be, what are the odds of losing twice in a row? So this is something you might not have learned before, and that's okay, I'm going to show you now. When you have independent probabilities, which we have decided as a class that each roll is independent, the odds of both of them happening simultaneously is the odds of the first one happening multiplied by the odds of the second one happening. And that's the odds of losing twice in a row. And that'll come out to about 0.277. So more likely than not, you're not going to lose twice in a row, but 28%, that's not that rare. And if we extrapolate this to losing 7 times in a row, well, it's the odds of losing once, then twice, then a third time, and it's 0.526 times itself 7 times, which we could write as an exponent of 7. And that is approximately 0.011, which is 1.1%. Pause. People are writing things down. So it is rare that you're going to lose 7 times in a row, but that's not 0%. And eventually it's going to happen, and that's when you're going to lose all of your money, and that house is going to catch up to you. Yeah.
But like, at some point you're gonna win. Like, no matter how like far down it's like, at some point you're gonna win. So like that like checks out.
That'll only win if you have literally infinite amount of money. If you had $1 million, eventually it'll happen. If you had $1 billion, eventually it'll happen. If you had $1 trillion, if you had any finite amount of money, eventually you're going to get on a losing streak that will make you lose everything. And if you had an infinite amount of money, you could do this and be profitable. But then why, if you had an infinite amount of money, you're probably not going to get too excited from gambling. Yeah, let's write that out. That's a very good observation. So, oh, by the way, this is called martingale. I don't need to know the name, but just for lore purposes. This is called martingale. And it only works if you have infinite money. If you have any finite amount of money, eventually you're going to get on a bad enough streak. And also just practically, casinos do have like an upper limit on how much you can bet, and so that would cap you as well. But just conceptually, this is true as well. Questions on this? Let's see. So I want to outline again sort of the thought process of a mathematician that's making these games. So this is a real job. Casinos or there are some game companies that hire mathematicians and create games for casinos that are always in the casino's favor. And I want to outline that, and then I want to give you the chance to come up with one yourself. So, given a particular game, the steps that they go through after they create a game, they determine the chance of winning given that. So they determine the chance of winning. And after determining that, they would consider what would be a fair amount to pay them. If this was a perfectly fair game, and we just wanted everybody to have a good time, what would be the fair amount to pay out? So they answer that question next. Determine what the fair payout is. And once they know what would be fair, they pay slightly less than that, because they got to make some money. And just to recap, like the roulette example, let's think about the odds of winning on a particular number. So roulette, winning on specific number. And we know there are 38 numbers, and so the odds of winning, 1 out of 38. And a tougher question that we haven't answered yet is what would be fair? Well, if you're going to win 1 out of every 38 times, and the other 37 times you lose $1, when you win, you have to make up all that money you lost, which is $37. That would be fair. If they paid you $37, on average, nobody would win, nobody would lose, but they don't pay you that. They pay you a little bit less than that, which is $35. And this framework here is what powers every single game in the casino and why these games are unbeatable. Because they just go back to math. There's no superstition. It's just math. And I want to give you the chance. I'm going to give you a game, and I want you to tell me what you would charge or what you would pay out if you were playing, if you were a mathematician making this game. This will be an activity that takes us a little bit. So, let's say we have the following game. We're going to roll 2 dice, each labeled 1 to 6, standard dice. And let's say that you win if you roll a 7 in total. We add the 2 together. And you lose on anything else. If you were a mathematician and you were presented this game, what should you pay out for a win? Out on a $1 bet. This is not an easy question. I think a lot of the other questions have been intuitive. This is a question that's going to maybe take a little bit of writing and a little bit of discussion. But I think it'll be a good exercise. And I want you to try it on your own and with the people around you. And there's not one answer to this question, because once you come up with the amount that you think would be fair, it's kind of up to you on what you think you should pay. But I want to give you the chance. Start by thinking, what are the odds of rolling a 7? And that's the hardest part. And then go from there. You find this is a hard question? Maybe?
Yes.
Let's throw some ideas out there. What are the odds of rolling a 7? And what are some ideas that we could come up to answer this question?
The chances of winning are 6 out of 36.
Okay, a lot. That was a good answer, but there's a lot to digest there. So I heard 6 out of 36. So where do each of those numbers come from? Let's start with the 36. Where does the 36 come from? You want to answer?
I multiplied 6 and 6.
So yeah, for each die, there are 6 possibilities. And so let's say the first die rolled at 1. Well, the other die could be 1, 2, 3, 4, 5, or 6. There's 6 possibilities there. What if I rolled a 2 for the first die? Then there'd be 6 possibilities again for the other die. And so for each of the 6 possibilities on the first die, there are 6 possibilities for the other one. 6 times 6 gives you 36 possibilities. And one thing that I might have heard is, instead of going for 36, I might have heard the number 11 or 12. And that would come from considering what are the possible outcomes when you roll 2 die. You could roll a 2, a 3, a 4, all the way up to 12. And that's 11 possibilities. And so it seems like we have 2 different answers here, but one of them is correct. Have you ever heard the joke that like you have a 50% chance of winning the lottery, it either happens or it doesn't? Terrible joke. Nobody? Okay. The issue there is obviously that even though there's only 2 possibilities, they don't have an equal chance of happening. Same thing here. There are 11 possible outcomes, but they don't all have the same probability of occurring. If we looked at 2, how many ways can you roll a 2? Yeah, and that's it. There's one way to roll a 2. Now back to this question, how many ways is there to roll a 7? We heard the answer 6. Let's see if that's true. We can just count them out. Yep, 2, 5, 3, 5, 2, and 6, 1. 6 possibilities. And so your chance of winning here really is 6 out of 36. Which we could simplify to 1 out of 6. And that was the hardest part. We found the probability of winning is 1 out of every 6 times. And so if we were playing a fair game here, how much would we have to pay out? If 1 out of 38, the fair payout was $37, what would be fair here? $5, because 5 times you're going to lose, and so you got to make up for that amount would be $5. And so if you're a mathematician,